Hello everyone. So in this video we will see how to solve logarithmic inequality. So the concept related to this, what are the important points for which are required for solving logarithmic inequality, we have discussed in the previous video. So if you have not watched that video, please go through that video because then only you will be able to understand this video. Okay, so let's start then. Uh, let's solve some very basic questions so that you will be able to understand how to solve the logarithmic inequalities and what are the points you have to keep in mind. Okay, so for example, you have a question that you have to solve log 3 minus x to the base 2 greater than 1. Let's say you have to solve this inequality. Now what is the solution of this inequality? You have to find, right? Now first thing, when you are solving any logarithmic inequality, you have to keep in mind the domain, right? So first condition is 3 minus x should be greater than 0. Why 3 minus x should be greater than 0? Because otherwise this log will not be defined. So here you can say x should be less than 3. This is the condition for domain. That means we can accept only these values which are in this range. X is less than 3, right? Now, what is the solution of this inequality? How will you solve this? So you can see 3 minus x. If I take this 2 on this side, this is 2 raised to 1. So this is 3 minus x 2 raised to 1, right? 2 raised to 1. Now the question is, sign of inequality will remain same or it will change. So we will say sign of inequality will remain same because, why? Because this base is greater than 1. So here you can say this is 3 minus x is greater than 2. That means x is less than 1. Okay, you can just arrange this and this is x is less than 1. So now what is the final answer? Here what is the domain? X is less than 3 and the solution is x less than 1. So we will take intersection of first and second. Okay, so what is the intersection of first and second? We will say x is less than 1. That is the solution of this equation. Okay, you have to keep this point also in mind because otherwise those values which are out of domain will not be acceptable. Okay, so that is why we have to put the condition of domain also, right? So now let's say you have some function fx which is log modulus of x to the base x minus 3. Now I ask you, what is the domain of this? That means what is the set of values of x for which this is defined? Let me write it on the next page. Let's say you have fx which is log modulus of x on the base x minus 3, right? X minus 3. Okay, so now if I ask you what is the domain of this, that means you have to find those values of x for which this expression is meaningful, it is defined. So now for log to be defined, the base should be a positive value. So you can see modulus x is always positive. If modulus x is always positive, the only thing is modulus x should not be equal to 0. Modulus x is always non-negative. So that is x should not be 0. Modulus x should not be 0 because otherwise this log will not be defined. Second condition you have to put will be x minus 3 should be greater than 0. That is base should be greater than 0. And the third condition you have to put for log to be defined is base should not be equal to 1. So from this, what is the condition? X should not be equal to 0. From this, x should be greater than 3. And from this is x should not be equal to 4. So now if I take the intersection of all this, you can say this is x belongs to 3 to infinity except 4. 0 is also already it's not in the in this set, so we can we don't have to exclude that. Okay, so this is the domain of this, right? Now let's say you have a question that you have log x minus 3 modulus to the base 1 by 2 is less than log base 1 by 2 modulus x. Let's say you have to solve this inequality. Now what is the solution of this inequality? Now in this case you can directly say that, see, modulus is always a non-negative value, right? So the only problem is x should not be equal to 3 x should not be equal to 0. These are only for domain, correct? Because this is always a non-negative value, so no need to put a condition for negative. This is also a non-negative value because modulus are always non-negative. So the only problem will be when this will be 0, this will be 0. Now, what will be the solution of this inequality? You can see here the base is less than 1. Now, if base is less than 1, we know that sign of inequality will reverse. So, this is why we will say this is x minus 3 modulus is greater than modulus of x. Now, how will you solve this? Now, since both sides are positive side, both sides are of same sign, you can directly square on both sides. You can say this is x minus 3 square should be greater than x square. So, now if I solve this, this is x square minus minus 6x plus 9 should be greater than x square. So now if you solve this, you will find this is x is less than 9 by 6, right? This is x is less than 9 by 6 or x is less than 3 by 2. So what is the final answer? Final answer we will say x belongs to minus infinity to 3 by 2, but there is a problem. What is the problem? That we cannot have 0 because at x equal to 0 this value will become 0. 3 is already excluded from this value, this interval, right? So what is the answer? This is x is less than 3 by 2. That is the answer for this question. So I hope you understood the basic idea that when you are solving the log inequality, you have to be very careful about the base. Okay, so now let's move to the next question, that you have to find the domain of this function, which is fx is equal to under root of log 5x minus x square upon 4 to the base 1 by 2. That means you have to find those values of x for which this is real. Okay, so now see, for the first thing you can see this log will be defined when this quantity, that bracket, should be positive. So you can say this is 5x minus x square divided by 4 should be greater than 0. This is for defining this log. Okay, so this is the first condition. I'll solve all the conditions together. Okay, now the second condition, you can see in the square root. In the square root we cannot have this quantity negative, otherwise this will become imaginary quantity, square root of a negative. So this should not be a negative value. So that is, you have to put a condition that log 5x minus x square divided by 4 to the base half should be greater than or equal to 0. Correct? So from this you can say this is 5x minus x square divided by 4. Now if I take this base on this side, so this will be half raised to 0, but sign of inequality will remain same or it will change. We can say the base is less than 1, that means the sign of inequality will change. So this will become less than or equal to 1 by 2 raised to 0. So now you can see this is 5x minus x square divided by 4 will be less than or equal to 1. So now we have this inequality to solve, we have this inequality to solve. So now if I solve this, you can clearly see this is x square minus 5x less than 0, just taking negative sign common, or this is x into x minus 5 less than 0. So if I solve this by using wavy curve, you can clearly see this is x is between 0 and 5. You can check by using wavy curve method, right? Now if I solve this, you can see this is 5x minus x square less than equal to 4, right? So now if I arrange this, this is x square minus 5x plus 4 greater than or equal to 0, just taking all the terms on this side, which is x minus 4 into x minus 1 greater than or equal to 0. So if I just write the solution of this, this is minus infinity to 1 closed union 4 to infinity, right? So all these inequalities basically can be solved by using wavy curve. So if you are not comfortable with wavy curve, you have to go through that those concepts also. Okay, so now what we will do is for the final answer, we have to take this is the first condition and this is the second condition. So we have to take the intersection of these two because both the conditions should be satisfied. So if I take the intersection, I'll just write it here. This is 0 and 5, the first one 0 to 5, the second one is 4 to infinity, this is 1, this is 4, so this is minus infinity to 1, minus infinity to 1, yes, and 4 to infinity, this is 4 to infinity. So what is the intersection of these two? You can clearly see this is the common part, this is the common part. So this is x belongs to 0 to 1 open and closed, this is union 4 to 5. 4 will be closed because 4 is in both the condition, but 5 is open because 5 is not included here. So this is the domain of this function. Clear? I hope you understood this, how we put the condition, how did you solve the inequalities here. Okay, so now let's move to the next question that you have to find now. This is again on the same lines, you have to find the domain of this function fx. Now here we have log x minus 3 to the base 4, and then again on the base half, and then this value is on the base 5. So now you have to solve this, we have to find the domain of this. Now the question is exactly similar to what we have done in the first question, only thing is here we have different logs here. Okay, so now let's start with this. The first condition will be to define this x minus 3 should be greater than 0, because this log will be defined only when this quantity is positive, that means x should be greater than 3. This is the first condition. Now the second condition is, you can see log x minus 3 to the base 4 should be greater than 0. Why? Now why this should be greater than 0? Because this log, the second log, will be defined only when this quantity is positive. So this is why this is greater than 0. So what does this imply? X minus 3 should be greater than 4 raised to 0. Why 4 raised to 0? This is 4 raised to 0, right? Now sign of inequality base remains same because base is greater than 1. So this is x minus 3 should be greater than 1. Correct? So I'll just write these inequalities, then solution we will write in the final step. Okay. Now the third condition will be, you can see log base half log, then we have 4x minus 3. Now this should be greater than 0 because then only this log will be defined when this quantity is positive. Now if this quantity is positive, now understand this. You can see if I take this power half on this side, so this will become log base 4 x minus 3 greater than, less than half raised to 0. Now understand this, if I am taking half raised to 0, that means the base is less than 1. If base is less than 1, sign of inequality will reverse. So that is why half raised to 0, we have changed the sign of inequality. So this will give you x minus 3 is less than, this is 1, so this is 4 raised to 1, so this is 4, right? So x minus 3 is less than 4 in the next condition, because here the base is greater than 1, sign of inequality will be same, right? Now the last condition which you have to put, the fourth condition, that for this square root, this quantity should be positive. That means log base 5, log base half, log x minus 3 to the base 4 should be greater than or equal to 0. So now step by step we will remove all the logs. Okay. So if I remove this log, this 5 raised to 0 will come. 5 raised to 0 is a positive, this base is greater than 1. That means this will be, sign of inequality will remain same. So this is log half 4x minus 3 greater than equal to 1. Now if I take this power on this side, you can see half raised to 1. Now sign of inequality will reverse. So this will be base 4x minus 3. The sign of inequality will be reversed. So this is half raised to 1, right? Now if I check this, this is x minus 3 less than equal to 4 raised to 1 by 2, that is 2, 4 raised to 1 by 2. Sign of inequality will remain same here. So this is x minus 2 less than equal to 2. So we have x is less than equal to 5. Then from this is x is less than 7, this is x is greater than 4 and this is x is greater than 3. So now if I take the intersection of all the 4, so you can see this is x is greater than 3, x is greater than 4. So if I just check what is the intersection of all the 4, this is 3, 4, 5 and 7. Now x is greater than 3, this is greater than 3, x is greater than 4, this is greater than 4, right? X is less than 7, so this is x is less than 7, and x is less than equal to 5, so this is less than equal to 5. So now I hope you have understood what is the common between all the 4. You can say this is x belongs to 4 to 5, but 5 will be closed and 4 will be open. So this will be the domain of this. Okay, so I hope you have understood how we get the domain of this function here, right? So now let's move to the next question. You have to solve this inequality. You have log x minus 1 to the base 0.04 greater than equal to log x minus 1 to the base 0.2. Okay, so let's start then. So the first condition you will put will be on the domain. So what is the domain in this case? You can see this here also we have x minus 1, here also we have x minus 1. That means x minus 1 should be greater than 0, that is x is greater than 1. This is for domain, right? For log to be defined, right? Now if you have to solve this inequality, now the solution part comes. So you can clearly see this is 0.2 whole square, right? So or otherwise what you can do is you can change this. This is 0.2 into 0.2, this will be 0.4, right? This is 0.04. Okay, so now this is 0.04 square x minus 1 greater than equal to log 0.2 on the base, right? X minus 1, right? Now we can take this point 1 by 2 outside, so this will become 1 by 2 log 0.02 on the base, 0.2 x minus 1. So this is greater than equal to log 0.2 x minus 1, and if I take this here 2, and you can take this 2 on the power also, so let me write it here. Now you say if you have log of fx greater than log of gx on the same base 0.2, can we say this quantity will be greater than this quantity, or this quantity will be less than or equal to this quantity? So that will be dependent on base. So what is the base here? 0.2. So we can say here this will be x minus 1 less than equal to x minus 1 whole square. Why? Because now the base is less than 1, sign of inequality will reverse. Okay, so we have interchanged the sign of inequality. We have just reversed the sign of inequality. Now we will solve this. So we will say this is x minus 1 whole square minus x minus 1 greater than equal to 0. I am just taking on this side. So this is x minus 1 common. This is x minus 1 minus 1 greater than equal to 0. So that is x minus 1 into x minus 2 greater than equal to 0. So what is the solution of this? This is x belongs to minus infinity to 1 union 2 to infinity. Now what is the intersection? Because this is the domain, this is the solution, we have to keep only the values which are in the domain. We will say the final answer will be first intersection second. So what is the intersection of these two? You can clearly see x greater than 1 here. This is x between 2 to infinity. So what is the answer? X belongs to 2 to infinity. So this is how you can solve this inequality. Okay, now let's move to the next question. Now this is one very interesting question here. You have to solve this inequality log x square minus x to the base x plus 3 less than 1. Okay, So now you can just pause this video and try this, because here you will find a very important concept to solve this inequality. Okay, now here you can see this base is a variable. That means you cannot say this base is less than 1 or greater than 1. So if I take this base on this side, this will be x plus 3 raised to 1, but the sign of inequality will be same or it will change. That will be dependent on this x plus 3, whether this is less than 1 or greater than 1. So here you have to make two cases. So first let's write the domain of this, then we will solve the inequality. What is the domain condition? X square minus x should be greater than 0, right? So second, this x plus 3 should be greater than 0 and x plus 3 should not be equal to 1, right? The base should not be equal to 1. So what is the solution of this? This is x minus 1 greater than 0, that is x belongs to minus infinity to 0 union 1 to infinity. This is x is greater than minus 3 and this is x is not equal to minus 2. So if I just take the intersection of these three for the final domain. So what is the domain of this? We will take the intersection of all these three. You can see this is x belongs to, this is minus 3 to 0 union 1 to infinity, except minus 2. You can see minus 2 is in between this, so that we have to reject that minus 2 also, right? So this is the domain part. Now we have to see whether this, what is the solution of this inequality. Then in the final step we will take the intersection with the domain here. Okay, so let's start with the solution first. Now the first condition, if this base, that is x plus 3 is greater than 1, let's say this base is greater than 1, that means x is greater than minus 2. Let's say x is greater than minus 2. If base is greater than 1, now you can say this is x square minus x is less than x plus 3. Why less than x plus 3? If I take this x plus 3 raised to 1, correct? But here the sign of inequality will remain same, because we have taken a case that x plus 3, that base is greater than 1. So here if you solve this, this is x square minus 2x minus 3 less than 0, which is x minus 3 into x plus 1 less than 0, which implies x belongs to minus 1 and 3, right? Now this is the solution, this is the solution, that is this is the solution only under this condition. This is the solution only under this condition. That means we can accept only those values of this which satisfy this condition. Okay, so now we can clearly see what is A intersection B. Why we are taking A intersection B? Because we can accept only those values here which are in the domain, in the condition which we have taken. So here you have x greater than minus 2, here this is between minus 1 and 3, and you can see all these values are in this set also. So what is the intersection? This is x belongs to minus 1 and 3. Okay, so this is the first solution. We are not saying this is the final solution, because in the last we have to take the intersection with the domain also. I am just solving this for the this solution of the inequality. Okay, in the last step we will take the intersection with the domain. Okay, so now this is the first case we have taken. Now the second case, that is x plus 3, that base should be between 0 and 1. If I say x plus 3, that base is between 0 and 1, that means we have x is less than minus 2, right, and greater than minus 3, just taking this minus 3. So if x is between minus 3 and minus 2, now this base is less than 1 now. So here we will say the sign of inequality will reverse, because now base we have considered is between 0 and 1. So this will be x square minus x, it will be x plus 3 raised to 1, but here now it was less than 1, so now we will say this is greater than 1. Why? Because the sign of inequality will reverse when base is less than 1. So now if you solve this, this is x square minus 2x minus 3 greater than 0. So this is x minus 3 into x plus 1 greater than 0. So if I solve this, we will find this is minus infinity to minus 1 union 3 to infinity. Now which values of which solution set you will take? You will take only those values which satisfy this condition. You can see this answer is possible only under this condition. So what is the intersection of a and b in this case? You can clearly see x is between minus 3 and minus 2, and this is between minus infinity to minus 1 union 3 to infinity. So if you just observe here, this value, the solution set will be only between minus 3 and minus 2, the intersection of these two. Clear? So the solution, final solution, we can say we have got first union second. What is the first union second? X belongs to, first solution was minus 1 to 3. This is minus 1 to 3 union minus 3 to minus 2. So this is just the solution set. Now for the final answer, this values will be acceptable only when these are under the domain of the function or a domain of this equation. So now the solution set we got is, let me write it here only, this is x belongs to minus 1, let me write it here, minus 1 to 3 union minus 3 to minus 2, minus 3 to minus 2, right? So now we will take the intersection of these two. So let me draw the number line so that you will be able to understand the final answer. This is minus 3, 0, let me draw minus 2 also, 0, 1 and 3. So now let's plot. Okay, so this is minus 3 to 0, the domain part, minus 3 to 0 union 1 to infinity, union 1 to infinity, right? Except minus 2, so we will reject minus 2 also. Then let me put minus 2 open, right? Now minus, the solution set is minus 1 to 3. So what is minus 1 to 3? Oh, let me write it here, minus 1 to 3. So this is minus 1 to 3. Okay, and union minus 3 to minus 2. So union minus 3 to minus 2. So now you check what is the common between these two. So you can see this is the first part which is common, this is the second part which is common, which is the third part which is common. So what is the answer? X belongs to minus 3 to minus 2. You can see this is minus 3 to minus 2 union minus 1 to 0. You can see this is minus 1 to 0 union 1 to 3. So this is our final answer for this question. Minus 3 to minus 2 union minus 1 to 0 union 1 to 3. So this is the final answer for this question. So I hope you have understood this question. So you have to be very careful while solving the log inequalities for the domain and for the base. So these are the key points which you have to remember for the log inequality. So I hope you are clear with the log inequalities. So in the next video we will take the next part of logarithm. So that's it for now. Thank you.